Yeah. I don't know if you know, but a lot of people when they deal with oleo.
Yes, but I think you could learn me one or two things about that.
Okay, well, Alliansil is a block that's impregnated with a high 33, 36%, I forget the exact number. I think it's made by Reynolds, isn't it?
It's the company in Germany, KS, that actually perfected the technology for
Reynolds.
Either that or their Alcoa. I think maybe Reynolds also owns Alcoa.
Anyway, what it is they impregnate the block with silicone, and instead of putting a steel sleeve in like you'd see in like a Cadillac Star motor, they actually hone the cylinder, but the honing process has to be done with a special stone at a special speed, or you tear the silicone because the silicone is impregnated into the bore.
Yeah.
Okay, then when you're done cutting it, then you go in and hone it, again to a certain pressure, certain speed, so you don't tear the silicone, because the silicone is embedded in the aluminum.
Yeah.
Then you have a burnishing process, and what the burnishing process is a paste that puts high pressure and high heat and spins a pad, like a felt pad. It etches away, it's an etching paste, it etches away the aluminum, heats up the silicone and glazes the silicone on the inside of the board to make a silicone coating for the piston to ride on.
Yeah.
Because this is a very low friction, very smooth surface.
Yeah.
Now it seals better and it makes more power and is more consistent on expansion than a steel liner, which is the advantage of it.
Yeah.
The disadvantage of it is the block casting is very expensive because of the silicone content.
Yeah.
And the honing and boring process is extremely tedious.
Yeah.
It has to be done correctly or you damage the silicone and then it wears out the engine because it doesn't have the silicone coating.
Yeah, then that's bad.
So one of Frank's main job was to come up with a way to determine silicon crystal damage.
Yeah.
Okay, so this is done with an electronic surface gauge to tell us how smooth it is, as well as you actually put an acetate tape on here and put it under an electron microscope. Yeah. And you can see how much silicon is still attached.
Wow.
After you hone it.
That's a very specific problem you're working on, or very detailed.
Yeah, we want to do this before we put it in production. We also bought a CNC machine with the right cutting tool, and we also bought a CNC honing machine with the right honing and paste, and it cost us $170,000 worth of equipment, if I remember correctly. And as Frank said, he contacted Kobenschmidt, who's a German company who came up with the honing and etching process, got the process from them and how to test it, and then went through the testing procedure.
Yeah.
Okay, so it's a lot more than just putting the parts in the motor.
It is.
Right, because you want this thing to last a long time. That's the goal.
Yeah, because because you're selling it with warranty.
Yeah. Yeah.
So you saw that report that came back from
Chris told me. Came out good. Yeah. So we're actually thinking about bringing the microscope in-house. We actually found a company that makes a digital video camera that goes up to, what's the power on the digital video
500 times.
500 times.
Is what they had indicated.
So we're actually going to buy a digital video camera so we can run down here and put it on a computer CRT and see the damage to the crystals on every motor and every bore.
Wow.
We haven't done that yet. These are the sort of things that BMW does as a manufacturer, which is why the stuff lasts 150,000 miles. So what most people do is they either put a steel sleeve in or hone it badly and damage the crystals, and then the engine will wear out prematurely.
And also what we learned from the summer is the parts for the stroker engine, you're actually order them from BMW's OEM manufacturers as well.
Some of the parts, yes, the pistons come from Mali. There's the box right there, and that's who makes BMW's original pistons. And Mali puts the original coating on the pistons that BMW puts on the original pistons. And just so you know, any similar metals want to bond. Steel wants to bond to steel and wants to bond to aluminum. So since this is aluminum and the piston's aluminum, they would naturally want to bond. So they actually put an iron spray coating on the piston skirt. This is how the original piston is made too. Do you have a piston around the show?
Yeah, I thought I'd get a set of new ones instead of the set that had come out of that motor.
Yeah. And so it's called a Ferrostan coating. And it's invented by Mali does the process. They acid wash the pistons and put the Ferrostan coating on, so now we have iron running against aluminum. The piston's still made out of aluminum, but the rubbing surface is iron. It's just a few microns of it. This prevents the piston from galling and wearing out prematurely, but it only works if you have the silicone done correctly on the bore. So the art of this whole deal is, and it's a gold coating instead of a normal, you'd have a graphite coating that's black, so you have golden color. That's called Ferrostan.
Got it. So Mali, these are well known. And
that's the original equipment supplier to
OEM,
company, you'll send them motors like we run them for a few hours, you send them the parts out of them, they analyze the parts, they'll check the hardness of the piston, and they'll make geometry changes to the piston, send you a new batch. And this is why the development process takes so long.
So what do Mali think about this project? You think you're crazy?
No,
630 horsepower?
No, I think they're very excited about it and like it a lot, but you know, One of the reasons it takes so long to come to market is things have changed on the piston.
Oh, really?
Okay, yeah. I mean, originally they decided that the skirt had too much rock, so they changed the taper of the skirt.
Yeah.
They decided the pin boss had too much stress from hair and cracks, so they changed the bracing on the pin boss.
Okay, so Mahle changed this
Yeah, we run the engine
again.
a few hundred miles under varying loads and
Yeah.
RPMs. We send it back to Mahle.
Yeah.
Mahle actually Rockwell tests the piston for hardness to see how much the metal's been annealed. Then they saw it in half and put it under a microscope.
Yeah.
Then they look at the wear and the coating, and then they recommend changes. They change
Yeah.
them. You put it in run a few hundred miles.
Yeah.
Send it back again until Mahle says, "Okay, we bless it now."
Yeah.
Okay, and then you know it's going to last. And so you also have to work with your good suppliers. First of all, you have to have OEM quality suppliers.
Yeah.
Then you have to work with them in a cooperative way to get the product to last a long time. And the BMW does the same thing, I'm sure. I mean, I don't know what their exact process is, but they pick partners like Mahle and
Yes.
and that sort of thing for the same reason, right? Because they know what they're doing. It's really flexible.
Yeah.
Blue means it's really strong, and you play around with these braces until such time as the part has the least amount of flex.
Oh, yeah, that's right. So
Okay, and then you grow it so you make sure it fits. That
Yeah.
clears the hood and clears the shock tower.
Yep.
It's basically stitched together plastic. If you look at it close enough, you can see the pattern
Yep.
where it even glues the plastic together. And you can make it any color you want too. The weed whacker rolls come in red, blue, green, white, black, whatever you know. So if you like a color, you
Yeah,
can
yeah.
do a certain color. You
But that's the most not the most important.
This one's in black, obviously, so you can't tell it's grown in the part. It actually looks like a finished part almost when it's done.
Yeah,
And
prototype
you could even
machine.
sand them and paint them if you want to make them look really fancy. Like you could actually make one of these look like a production part.
Yeah.
It's not very cost effective at 100 hours
Yeah.
per part.
But
Because it's
looks
about,
good.
It's about $10,000 to grow one.
Really?
Between the plastic and the time.
Yeah.
Okay, so it's not really a cheap way to go into production.
No.
They're hooked together, and this is the taper, and this radius made 3 horsepower.
Really?
Yeah.
Where is exactly this radius?
You can feel it right here.
Okay.
See, it's rounded instead of just a square shoulder.
Yeah.
And this hits the air mass meter, so it's flush here when they're
Yeah.
installed, so it's a smooth entrance. And just this radius, you can feel it right here.
Yeah.
It's basically a Venturi.
Yeah.
The Venturi made 3 more horsepower.
Really?
Yeah.
And this here is this.
Is inside the air filter.
Yeah.
It's right there.
There. Wow.
So we originally had a straight one when you were here last time. The filter
Yeah.
was straight.
Yeah.
In order to make this, now we had to make the filter bigger to make room for the funnel.
Yeah.
Okay, then we had to show them. Then we had to put a bump in the box lid. If you can go back to the lid, because this hit the lid.
Yeah.
So see, there's a dome in the lid.
Yeah. You didn't have that last time.
No, that dome was to clear the filter, which is bigger, which was made to clear the funnel.
Yeah.
This is how
that's
these
right.
things cascade.
Yeah.
right?
Yeah.
People don't know why it takes
Change
so
one
long.
thing, change other
Right,
thing.
now you got to redesign the whole damn thing, right?
And I mean, if you find 3 horsepower somewhere, of course you have to take them.
Sure. I mean, this whole system with removing of the hydrocarbon absorber software, the bigger mass meter, the big filter, the taper,
Yeah.
was worth 20 horsepower total collectively.
Wow. And
The 3 of it was just this.
Yeah.
Right. So you can't leave 3 on the table out of 20. It's
no,
like,
no. And
we
what?
spent another month on just this stupid little thing here. Which, this is the dining way, right?
And what parts did you grow out of that machine?
Well, we grow this whole box here, the air mass meter, and the lid.
Do you have a sample here?
We're walking around. and
Perfect.
install-
Fred's got them in his booth as well.
Okay, we got one in one of the cars, right?
I
With
think
the dome
any
on
of the-
my car.
Yeah, I think it
My
is.
M5 has them on it. And then we also have seals against the double intake BMW.
Okay,
You know, most
okay.
aftermarket, they just put it under the hood and put a couple of plates that kind of direct the air in the right direction. What we found is when they suck really hard, it pulls air from underneath the hood where it's hot.
Yeah.
And pulls hot completely with a rubber boot. Just like
Okay,
the
to
BMW would.
avoid the hot air.
Right, to avoid
Yeah.
the hot air. So we
Yeah.
actually had to make hard tooling and actually make injection molded rubber boots
Yeah.
to attach this. Do we have one of those around?
Yeah, they're actually in parts. I can get one for you.
Could you?
Yeah.
Yeah, find us while we're walking
So here you have the prototype for the
around. Right.
airboxes, and they built up in parts since it's a prototype, and a prototyping machine cannot make these large ones.
And then this plugs into one of BMW's intakes, and the rubber boot goes here to plug into the other one.
Yeah.
So it engages in the double intakes that BMW has in the engine already, but it's sealed just like it was when it was stock.
Yeah, and important thing to have it sealed is to avoid the hot air around the engine, which decreases performance.
Right, because in reality, if it really does pull more air,
Yeah.
the air has to come from somewhere.
Yeah.
And if you don't seal it, it comes from any place it can get it.
Yeah,
It's the path
and-
of least resistance. It's
Yes.
air, right?
Yeah.
This
Just
will
like
also, if
electricity.
you're going fast enough, it'll pressurize and
Yeah.
Right, because you get ram air, you build pressure in the box, and you get power from ram air.
Okay.
But if
Yeah.
you don't, it bleeds off that ram air.
Yeah.
Just like the scoop you have on a Formula 1 car right above the guy's head.
That's right.
That's horsepower.
Oh yeah.
It can be 3 or 4%.
Yeah, ram air, like a lot of air going
Right.
in.
But in order to do that, you have to seal it to get the ram air.
Yeah.
Right. So you have to insulate it by making it out of plastic, which is why we make them out of plastic.
Yeah.
And you have to seal it to get ram air and avoid heat.
Yeah.
But then you also have to make the air filter flow more, the air intake flow more, the air mass meter flow more, and make sure that you don't cause any turbulence on the way in.
Yeah.
Right. This is all the engineering involved in doing it right.
Yeah, and only the airbox. And the shape of this, can you...
This is just the clear stuff in the car. You
Okay.
know, lines and hoses and bumps in the frame and all the things that BMW put in the way.
Yeah. and as you mentioned also, it's you have to think of both the M5 and M6, of course.
Yeah, because we want them interchangeable.
Yeah, and the M6 has less clearance above.
Which one has less, the M5 or the M6?
It would be the M6.
So the M6 has less in one spot, and the M5 has less in another spot.
Right, so it's not necessarily Fred did all the claying, where we actually put the lid on, we clay it, we close it, and we sit there with a ruler and check all that. We put like 50 clay blobs on the top.
Yeah.
Squish them from the hood.
Oh, and you see where the connection
and
point
see where
is.
they're close, because otherwise you'll get a rattle because it won't clear. And then you also do things like the Dinan way is we put a little mount for the windshield washer bottle filler attached to the side of it. I mean, it looks like a factory part when it's done, right? I mean,
and that's the point to have it.
Well, that's important, I think. I mean, a lot of people just leave that kind of hanging or make a cheesy little bracket.
And if you have like a 120,000 K M6 and you pay even more on it, you want to have everything perfect.
You have a picture of the clay or
I was
something?
going to see if I had a picture of the clays.
So Fred is how Dinan works is we have a fabricator that works on the car.
Yeah.
So Fred's an engineer fabricator, used to work for GM.
Yeah.
James is a solid model guy.
Yeah.
And then we have a software calibrator that works on the software. Then we have another guy that does a dynamometer.
Yeah.
Okay, so a 4-person team works on
For
it.
the airbox. Yeah.
Okay, and we've been working on this for a year.
Yeah.
Not full time. They have other projects too, right? But,
Yeah.
you know, and then there's $100,000 worth of tooling,
Yeah.
right, per side. So
Yeah.
$200,000 worth of tooling,
Yeah. So.
plus all the machinery and the computers and. Yeah, you can see how,
But-
you know,
but-
the cost of the airbox, and people go, well, if it's plastic, why does it cost $2,000? Well, you're not paying for the plastic.
No, it's a research.
Yeah. I mean, I say this to people all the time. You have a...
Oh, wow.
There's the picture of all the little clay mounds that I put on top.
You've been working a lot for a while there.
And then the measurements as to
This
how
is the
clear they
measurement of
were.
the clearance of each one.
Yeah, but because I mean the customer and I never sees this.
Right,
I mean,
never see that we go through all this.
You're the one. You certainly knows it.
And then you also have to check down in here where it clears everything with all these bumps and notches. And then you draw another one if it rubs somewhere, and you grow it again, you put it in, and you change it again. And we'll spend 3 months just making everything fit correctly.
Fitting is one thing, and also I mean, as you told me, the additional horsepower. If you found 2-3 horsepower, then put it in.
Yeah, of course. So we found like 5 off the air mass meter.
Yeah.
And then we found about 3 off the funnel going into the air mass meter. So 8 of the 20 is not actually even from the air filter or the airbox.
So
cold air intake, right? It's
so I wonder how much engineering and how many engineering BMW put into the airbox.
I don't think very much, considering what we found. It's my own personal opinion, but
when you see
it certainly
the
fits really well, the BMW one.
Yeah,
It just doesn't flow very well.
no, so it's do you have the stock or how does the stock
You have
airbox?
a stock airbox around?
Yeah, let me go find you one.
To the front of the car from BMW, and this allows it to move.
Yeah, because it's because the engine is a bit flexible. It's on rubber mounts.
We actually even have these made in 3 different durometers of plastic.
Yeah.
I mean of rubber.
Yeah.
50, 16, 70 durometer, and that's how stiff it is. And then we pick the stiffness that has the right amount of flexibility, but also won't crack.
Okay.
So not only do we make tooling for this, then we have them make them in 3 different samples.
Yeah.
And then we play around with the hardness of the rubber.
Yeah.
Because if it's too stiff, it pulls it off.
Yeah, and then
If
it's
too
no
soft,
use
it
anyway.
falls apart.
Yeah.
Right,
Something
so
in
it's-
between.
Something in between.
And
Well, yeah, there's always a compromise. I mean, sometimes you have to make it extra soft because the engine moves a lot, and you know they're going to deteriorate more rapidly than you like.
Yeah.
Sometimes you can get away with making it more rigid. Each car has its own story. You
Yeah.
sort of have to just deal with it as it comes. This particular car, since the air filter box is attached to the fender, and the scoop is attached to the front nose, they don't move relative to each other because this is in between the engines. So we picked the hardest durometer for this one.
Yeah.
Because we could, because there's not very much movement. It's just wind shake movement. Yeah. But if you put one between like an air mass meter and an engine, where the engine rocks back and forth a half inch, then these have to be pretty long and pretty flexible. Yeah.
Exactly. Too.
You know.
And here we're just standing next to a S62 engine,
This one's
M5.
coming off and this one's going on.
Yeah, and what
No, that's a Ferrari motor. We have a contract. This year with a Ferrari racing team's running in GT and Grand Am, so we're doing Ferrari 430 race engines.
Oh, lovely. Can't you please put those in the S3?
It's a neat little car. That thing makes 490 horsepower, a 4.3 liter motor
Yeah,
at 8,500 RPM.
Yeah.
Ferrari does their homework.
yeah.
It's really neat. It's got a dry sump on it, a little jack shaft running a water pump over here.
And but this is now stock 430 engine. It's
This is a racing version that Dusty's working on. Dusty's in charge of development in the engine shop.
yeah,
So this has got a racing harness up with a Bosch racing control unit on it.
Yeah.
Use the streetcar one. Dusty's been doing some development on the engine, and it's actually going to the GT race at Homestead in 2 weeks in Florida. So we're overnight freighting this to Charlotte to get installed.
so you approve Ferraris. You like Ferraris as well.
Ferrari's are great. I mean, I'm the BMW guy, but it's not the only car.
And I also remember your Augusta MV
got one of those too,
or Augusta that you got this summer.
Yeah, it's a nice bike. I like that thing too. Yeah, I just like neat machines. You know.
Yeah, like everybody.
Yeah, we're all car people. Procedures, build sheets, how to measure to make sure they all come out the same. So he's building the procedure. He's also building every one of the engines for the time being until we feel that it's 100% perfected, and then we'll add an assistant on that. But